Soldier Boy tough. Hey, I got this new dance for y'all called the Soldier Boy.
What's up, homies? Welcome to the lounge with Jen. I'm DZ. On today's show, we got Francesca Jugs. She's a hella famous physicist. Welcome, Francesca Jugs.
I'm going crazy, sitting back just staring at this lady, so damn fine.
Hey, what did you girl? How you doing?
Well, thank you. I'm doing good. How about yourself?
Just chillaxing, show. So, tell us a little bit about yourself.
Well, I all came to be back in 1977 when I graduated from the high school, whatchamacallit. Then I decided to go to the prestigious University of Eden Newton. There, I decided to become a major in physics and specialize in quarks.
And it's interesting. So, let's get to it. What is a quark?
A quark is one of the fundamental particles of matter. Quarks combine to make up protons, neutrons, and hadrons. It takes exactly 3 quarks to make 1 hadron. There are also particles called mesons formed by quarks and antiquarks. Baryons make up of either 3 quarks or 3 antiquarks. Hadrons fall under the baryon category. They are the only particles believed to interact through all 4 fundamental forces, which are gravitation, electromagnetic, weak interactions, and strong interactions.
Alright, it's all good, it's all good. But we gotta go to commercial now, so stay right there.
Scientists of the early 20th century believed that all matter is composed of 3 particles, protons, neutrons, and electrons. They also thought that these particles could not be split into anything smaller. However, by the late 1950s, this simple model could no longer explain all the particles that physicists had discovered. In 1964, American physicists Murray Gell-Mann and George Zweig developed a theory of particle physics that said quarks were the building blocks of protons and neutrons. Gell-Mann got the word quarks from the 1939 novel Finnegan's Wake by James Joyce. They discovered the up and down quark. In 1970, American physicist Sheldon Glashow, Greek physicist John Iliopoulos, and Italian physicist Luciano Maiani developed the theory of a 4th quark, called the charm quark. In 1977, the bottom quark was discovered, and in 1995, the top quark was found.
Welcome back to the lounge with Jen. I'm DZ. On today's show, we got Francesca Jugs. So, Francesca, how many quarks exist?
Well, current theory and data suggests that only 6 quarks exist. They cannot be split into anything smaller. The quarks have 6 different flavors or species. Most physicians talk about the 6 quarks in terms of up and down, charm and strange, and top or bottom. Quarks have a fractional charge, unlike protons and electrons, who have a positive 1 charge and a negative 1 charge respectively. The up quark has a positive 2/3 charge, and the down quark has a negative 1/3 charge. The charm quark has a positive 2/3 charge, and the strange quark has a negative 1/3 charge. The top quark has a positive 2/3 charge, and the bottom quark has a negative 1/3 charge. Protons is made up of 2 up quarks and 1 down quark. Neutrons are made up of 1 up quark and 2 down quarks.
Alright, well, we gotta go to commercial break now, so stay tuned. We'll be right back to talk about more quarks.
Because of the theory of color confinement, scientists cannot directly measure the mass of quarks, but have to estimate them by studying hadrons. The theory says quarks cannot be isolated because there are force fields that hold them together. If a quark stretches too far away from the other quarks, the force field between them will snap and the loner quark would just form another quark and an antiquark pair. These force fields are caused by gluons, which are particles that cause quarks to interact with each other. Most of the mass in protons and neutrons are from the energy given off from the gluons. The theory of relativity supports this. It says that quicker moving particles have more energy and therefore seem to have more mass than particles at rest.
Welcome back to the lounge with Jen. I'm DZ. Francesca, what is quark matter?
Well, quark matter, or QCD matter, is the theory that in extreme temperatures and densities, quarks adopt phases. And densities harden, melt, and their quarks become free and roam. It is believed that after the Big Bang, the temperature of the universe was so extreme that this was able to happen. All matter was like plasma. Also, some scientists believe that because neutron stars are so dense that quark matter exists within them.
Alright, well we gotta go do another commercial break. So again, don't touch that dial or I'll shoot you.
The standard model of particle physics was created from thousands of years of research, but it has only been recently that scientists have been able to experiment with quarks. In order to test particles today, scientists use particle accelerators, inspired by Ernest Rutherford's idea of using a particle beam, a target, and a detector to study particles by colliding them. Colliding two particles that have short wavelengths temporarily free quarks and gluons, so that physicists can study them.
Welcome back to the lounge with Jen. I'm Deezy. That's all the time we have for today's show. So Francesca, got any last words?
Well, to this day, physicists are still trying to learn about quarks. In 2003, physicists found evidence of 5 quark particles after 30 years of research. Quarks are also important to nuclear scientists because they help them better understand the nuclei of atoms.
Alright, well thank you Francesca. Jugs. On next week's show we got a special appearance by Mr. Schlutzbaum. Bye.